We're studying IGCSE maths and we're starting angle properties and circle theorems revision 3. This is the third class on the revision. And in the last class, we have done all this already. We did angle properties to recap. And before that, we did circle theorems. Now today, agenda is basically solve questions. Now, I gave you a worksheet on similarity. Lula, Diana, Niranjana, have you done it?
Yeah, I've actually finished it, and I was planning on submitting it, but I had to do other things, and I have to rewrite it again.
Diana, what is your excuse?
Sir, I wasn't there when you taught us similarity.
All right. Still, I want you to go through the worksheet and ask. So whatever you can do it, and ask me for doubts.
Okay, sir.
Because you have done it in school already, right? You have to revise.
Yeah.
You're going to school, and in school you have to ask doubts as well and solve questions so I can help you with your doubts. But learning happens in school, doubts happens here. Fine. Now, circle theorems, polygons, and all of this. Fine. Let's start with a question. Before we start with a question, Najla, I want you to start reading from here. Polygons.
You want me to? Okay. Sum of angles at a point equals 360 degree. Angles on a straight line equals 180 degree. Sum of angles in triangle equals 180 degree. For a regular, okay.
For regular polygon, external angles is equal to 360 divided by n. Internal angles is equal to 180 minus 360 divided by n.
Niranjana, continue. Diana, continue.
For irregular polygon, sum of exterior angles equals to 360 degrees. Sum of interior angles equals to 180 and minus 2.
Okay. Now, that's done. That's the revision of what we have done so far. These formulas should be in your notebook as well, and they are also in your notes. This Z notes is in the GCR, the latest version. Don't use the old version, please. Next one is whenever you have a line like this, which is X, and you have opposite angles, they are going to be equal.
Sir, in the GCR, when we check date-wise, we only find everything that's from September and below.
Yes,
Yeah.
because I think because it has not been updated in a long while. All right, the recordings are all there. I just have to make an entry for it. So we'll do it because I've been quite busy. That's the honest thing, right? Now, if you want a specific class, message the team directly. They'll send you the link directly from the database. So they'll send it to you directly if you want something specific. Now, corresponding angles are equal. Anything that makes like an F kind of thing, they're going to be equal. Now, I think we have done this. If you have a Z kind of thing, these are called alternate angles. If you have a C kind of thing, they're called co-interior angles. They add up to 180. Fine. Next thing is, if you have a triangle and an external angle out here, then this opposite angle to the exterior angle is always going to be equal to it. So B and B are equal on the opposite sides. Lastly, we have circle theorem. What this means is if you have a circle, which looks like this, and if let's say I make a shape like this from these 2 points, A and B, and I make another shape or line, 2 lines, but instead of the circumference, because this red part is the circumference, that's the outer region of the circle. Diana, what is the circumference?
What, sir?
What is the circumference?
The outer
The outer
circle?
part of the circle, yes. And we also have the center right here in the middle. So what we realize is whatever is angle at the, if I have two common points, so A and B is common for both these shapes. If I make it a different color, perhaps I make it black. So the black and purple shape, they both have A and B as common. And by these common shapes, if I get the two angles here and here, this one, A and B, whatever angle is at the center will always be twice of the angle at the circumference. So whatever angle is at the circumference, it will be twice over here. Is that clear? Any questions? Let's look at a question for this actually. Just a second. Now, next one. Before I continue, Najla, read the rule.
Angles at center equals twice angles of circumference.
Angle of circumference. The next one is if you have a circle. Let's make a circle right here. You have 2 points, A and B. And if I make any other shape with the same points, all of the angles, let's say this angle is H, let's call this guy H. Let's call this K, and this one B. H is equals to K, and this is also equals to B. All of these are same. Why? Because A and B are common, and they are in the same side of the circle. This part. This is called segment. Segment is because if I divide the circle in two parts, let's call this the first part, and this is the second part. So in this upper region, if I make any shape, they're always going to be equal. The angle is always going to be equal. But if I make another shape right here, let's say this one, the angle of this, if I call it A, is not equal to these guys. Because that's not in the same segment. This and this are segments. Mavada, have you done this in class?
Yes.
All right. Any doubts so far? Ask me. Now, what we're going to do actually is, I'm going to give you a few questions to solve. And the rest of you, Najla and Mavada will revise it. The rest of you solve questions. Because we have done this already. You have the notes. You also want to revise? You have to revise it from the notebook. First, let's try with the question.
Yes,
Or let's solve the question then. Let's start with the question. Everyone focus on the question. Question 1. Now, over here, what's happening is I have these two shapes here. This purple one and this other one, which is, let's make it with another color, red. Now, what you'll realize is that both have the common point A and B, yes? Right? A and B, they form with the same arc. What that means is this is the arc they have. Or they have the same point, fine. And if I join A and B, this will make two sides of the circle. Side 1 and side 2. What this means is if I have this circle like this, and I have 2 points A and B, and I make a line joining these, this will give me two parts of the circle, the top part and then the bottom part. Both of these parts are segments. Now, the angle Y will be equal to 56 if it is in the same segment. Now, what we realize is, since these are in the same segment, they are going to be equal. The angle Y and 56. Why? Because, or why will they be equal? Because if I look at the second rule, Najla, read the second rule.
Angles suspended by the same arc at circumference are equal.
Equal. Now, because they have the same arc, what is the meaning of an arc? Arc is if I have 2 points in a circle, if I have 2 points in a circle like this, this part is called the arc. And this part is also called an arc, the top part. But what we realize is we get 2 arcs when we make 2 points, A and B. One of them is a bigger arc, or what we call it is a major arc. Everyone write this in your notebook, draw it. This part, major arc, this is called a minor arc. Now, since both of these points, or let's say if I make a shape like this and another shape like this, both of them have the common arc, don't they? Mabadda, do they have the common arc?
Yes.
A and B. The blue part is common for both of them. And if I join these points like this, I'll get a different kind of thing. I'll get 2 segments. Now make this diagram in your notebook, both the arc and the segment part. Tell me when you're done. Niranjana, Lula, Diana, I want you all to make it. Now this is called a segment. Blue part, that is major segment. This is called minor segment. And this line right here is called an chord. Draw this quickly, tell me when you're done. Also make another circle. This is the center. This is the radius. And this whole thing from here to here is called the diameter. Diameter is equal to twice of radius. Tell me when you're done making it. Quick. Diana, Niranjana, any questions?
No, sir.
No. Najla, have you finished drawing it?
Yes, sir.
Niranjana,
Yes, sir.
finished drawing?
Yeah.
Good job. Let's look at this question again. Now, okay, if I join these 2 points, I get a chord. And that means I have 2 segments here. Yellow part and the blue part. Since these two shapes, the purple one and let's say the green one have the same arc. Do they have the same arc? Yes, because look, this is the arc they have. And if they have the same arc and they're also in the same segment. So they're going to be equal. So what is y? Can you tell me? Najla, what is the value of y?
It's equals
Equal to?
angle x.
Not x, 56. Now it must be at the circumference. X is at the center, right? So what we're
Okay.
trying to do is, when I make two shapes like this, they have a common point A and B. Then always they're going to be equal. The angle is equal. If I make another one right here, like this will also be 56. If I make another one right here, it will also be 56.
So
But
we
if I
don't
make it,
consider the
we don't consider the
center, so we can't
no,
put it 56.
no. Center is not at the circumference. It must be at the circumference. And look at the rule.
Okay.
The rule says angle subtended by the same arc at the circumference. Fine. So I hope no one has a doubt with the second rule. Niranjana, any questions? Second rule.
No doubt.
So therefore, y must be equal to 56. We'll also give the reason here. They're not asking for it. We'll just say it. Because in
We
paper
can
4, they will
say
ask you.
angle at circumference.
Angle, let's say, subtended by same arc at circumference are equal. There's one more thing we'll add in the same segment. Now, Lula, can you read what rule I gave you in your notebook? For the second rule, quick.
From the previous class or here?
Yes, previous class, not this one. Because I think we have done this so many times, right? That is why it's a problem. Since if someone new joins, then we'll have to go it all over again. So if you have any friends, all of you who want to join, please tell them to join quicker, because after some time I will not be revising anything.
We
So
wrote
they'll have to.
arc subtended by common arc in the same segment are equal.
So let's forget the circumference. Yeah, that's fine. And then Lula, add this word there as well. Add circumference.
Okay.
Add it right now, and after the class, send a picture of all the rules in the group. Fine.
Okay.
Now we look at the second one. Najla, Mawadda, any doubts?
Yes. No.
No.
Now let Niranjana come back and I'll ask her as well. Now let's look at the how do I find x? Well, now where is x? Is x at the center or the circumference?
Center.
Center. Now since this is at the center, okay, I'll look at any of these. Since this is also 56 by the way, let's write it right there. 56. And if I choose this one, let's read the second rule. Diana, read the first rule, rule 1. Diana. Najla, read the first rule.
Angles
me,
at
sir.
Diana, continue.
Can you repeat the question?
Question is, read the first rule out loud.
Angle at center equals twice angle on circumference.
Right, and guess what? We have angle at center and angle at circumference. And we know that angle at center is twice of angle at circumference. So this will be 2 into 56 degrees, which will be how much?
112. 112.
12. So the answer is x is 112. The reason is you need to give the reason. Even though this is paper 2, they don't ask for the reason, but in paper 4 they will ask for the reason. So we'll just say angle at center is twice or double of angle at circumference. Now for the first two rules, Najla, any doubts? Mawadda? Niranjana?
No.
Niranjana? Let's look at another question then. Question 2. Now for question 2, we have a lot more things happening here. We have this line. What does this line mean? That means that these two
They're
lines
equal.
are equal. Yes, equal. Now, okay. They're asking us, Diana, read the question.
ABCE is a cyclic quadrilateral. AED and BCD are straight lines. AC equals to CD, angle ABC equals to 45 degree, and angle ACE equals to 20 degree. Work out angle ECD.
Now, Luna, quickly send me the rule on cyclic quadrilateral from your notebook in WhatsApp.
Okay.
Take a picture and send it. Now let's go to rule number 4. Najla, read the rule.
Opposite angles in a circle quadrilateral
Cyclic
equals
quadrilateral,
equals 180 degree.
180. So cyclic quadrilateral. What does that mean? Well, if you have a circle and you have a quadrilateral, quadrilateral is a shape with 4 sides. If you have any shape with 4 sides and all the points are on the circumference, the opposite angles will add up to 180. Always. So if I have H and K, Mawadda, if I add H and K, what will I get?
180.
180. What if I add A and K? What will I get? Najla.
Again 180.
No. Because we can get anything. Okay? Or we can say
They're
we
on
don't
the
know.
but they're on the same arc of
Same
the
side, right?
circumference.
No, but they have to be opposite.
Okay.
If you have a shape like this, a quadrilateral with 4 sides, how many sides does it have? 1, 2, 3, 4. If you have a shape like this, then only the opposite angles add up to 180. So H and A and K, I don't know.
Okay.
Just say IDK, right? How you guys like to write it in chat? IDK, right? So I
Yeah.
hope you understand now. Any questions? Let's go to this question now. Now I know what 45 is, because it's there, obviously. Can I find this angle? Tell me, what is AEC?
45 minus 180.
So angle AEC is going to be 180 minus 45. Because 180 plus is equals to 45 plus angle AEC. Now, why am I calling it AEC? Can someone tell me? How does the name work?
We're calling it
Because-
AEC because it's a triangle.
No.
Because
Mawadda,
on the
who was the
center.
other one? So, okay, Najla, right? That's correct. Look, A is the point here. If I make the angle like this is my angle. So I'll take side A or C. I can call it, say, CAE, like this one, or I can call it AEC. So this E must be at the center because that's where my angle is. And the other 2 points are A and C. Is that clear? That is how we name an angle. If I have, let's say, an angle like this, ABC. This is a triangle ABC. To represent the triangle, I'll say ABC. But for an angle, I won't use the triangle symbol. I'll use this symbol. And let's say I want you to find the name of this one, X. What is the name of this angle? Tell me.
ABC.
What is the name of X?
Huh?
ABC. Anyone else?
Angle
ACB.
X.
Say that
Wait,
again.
no. ACB.
CAB.
ACB. We can not CAB because C must be in the center. It's in the center, right? So this will be in the center. I can also have DCA because I start here, go like this.
So
But I can't
angle
have,
at the center should be in the center, even by writing it.
yes, always. That's how we name it. So right now they're telling us that ACE is 20 degrees. ACE. So angle ACE, this one. So I start at A, I go to C, then I go to E. So C is in the middle again. Is that clear?
Yes.
Now these are small things which you should learn in school. But my job is to find what you don't know and to help you revise everything. I hope you don't have any doubts with this anymore.
No doubts.
No doubts. Now I know that 180 is going to be, since this guy and this guy are opposite to each other. So 180 is 45 plus. What is the angle this X? Najla, angle X is
AEC.
AEC. Now to find AEC, all I have to do is take 45 to the other side. It will become 180 minus 45.
Which
And the
equals to
answer will be
135.
135. I know what this is now. Fine. 135. All right. Now my job is to realize what are we supposed to find? We're supposed to find ECD. This one. That's the main goal. Okay. Now if somehow I can find this angle, then I can find X as well because they're on a straight line. And angles on a straight line add up to 180. That's the total. Fine. Now, let's look at a few things here. The first thing is, if I know that this is 35, all right? Yes, that's 35. All right, let's see how this works. Now, if I make, let's say, a shape, I'll just add a line right here. Okay. Now, can someone tell me what is this angle equal to? I want you to focus on these two shapes, this one and this one. What is angle, let's say, G equals to? Think and tell me. Niranjana, work with me. Mic on.
It's equals to half of 45.
Half of 45, which is 22.5. Right? Then what is this one?
The same.
The same.
No, oh, wait, no, not at all. Why is it half? No, it's not half. I want you to look at the second rule, which is angles subtended by the same arc at circumference are equal. Angles subtended by the same arc at the circumference are equal. So if you look at this one right here, don't they both have the same point? Angle 20 and G. They both have A and E, right?
Yeah.
So therefore G will also be how much?
20.
Why?
The reason angles subtended by the same arc
Are equal. Niranjana, can
are
you hear
equal.
me?
Yes, sir.
Niranjana, all right. You have these two shapes right here. Now I know that the points are common, A and E. Both the shapes are formed by the same point, and both of the angles are at the circumference. So I can find
Yeah.
what this guy is, because since both of them are at the same place, same circumference, same point, so this will also be 20 degrees. So because of that, now I can find how much is this angle right here. How much is that? Niranjana, tell me. The full thing is 45. So
Yeah.
and this is 20. So how much is left here?
25.
25 degrees. Fine. Now next thing is, we know that this whole thing was 135 degrees. Okay. Now give me a second on this question. I'll give you something more easy than this. Try solving this one. Start. Everyone, I need the answer in the chat for this one. This question has the only rule 1 and 2 in it. Or I just want you to find what is, if I tell you that this angle is also 28, what is x? Tell me, answer in the chat. Quick. No, Diana, try again. What is the total angle in a triangle, Diana?
180.
180. So what will all these angles add up to?
180.
180 is equals to, yeah, so it should add up to 180. So x plus 28 plus 28. Because this whole thing is a triangle. Niranjana, tell me what is x now?
124.
How much?
124.
Wait, is that 28 or
28.
128?
That's
Oh,
28.
okay.
Now, so x is equals to 124. Now, I want you to find what this angle is. This is the first rule we have done. Angle at center is double of angle at circumference. So what is the angle x now? Or let's say y.
Is it 64?
It is 64 because since x is twice of y, so I know that x is double of y. Or let's say,
Sir,
yes,
O is equals to 124.
124.
Yeah.
It's not O, it is AOB, right?
Yeah.
Now 124, we have this. I know that 124 must be double of y. So y is 62. Any questions?
No.
No. Now the angle they're asking us find ACB. We found ACB, which is 62. You have to show all the workings. If you don't show the working, you'll get 1 mark. And they are also asking for reason. So what is the reason for the last one, Navadha?
Angles at the same arc are no angles. The angle at the mid center is double the angle on the circumference.
Circumference. Now,
Yes.
why was this 28 equal to this 28? Because AOB, the triangle AOB, is
Isosceles?
isosceles. Why is it isosceles? Because whenever you have any shape like this, these angles are always going to be equal. Because look, this is R. Oh, what is OB? Can you tell me? Or if I have a circle right here and you have the center, what is this line? Check the notes from previously in this class. What is this called? This is called this is the center O, fine. But the line is called radius. Is that clear? This line is radius. Which we did right here, R. R is radius, by the way. D is diameter. Now, what is diameter equals to compared to R? Diameter is equals to 2 times the radius. How much?
2 times the
Twice the
radius.
radius.
Twice the radius. Because diameter is basically, if I extend this further, that becomes the diameter now. Now, since I know that this is the radius, R, OB is radius. So what is OA? Is OA radius? What is OA? Tell me. Is it radius or is it not radius?
It's radius.
Because it is from the center to the circumference. Center to
Yes, it
circumference
is
always.
radius.
This is radius as well. Thus, as both of them are radius, okay, R and R, then I know that if two sides are equal of any triangle, they are isosceles. If this is 2 and this is also 2, then this angle will be equal. This is called an isosceles triangle. Now, this is not the radius, this is not anything. Is AB the diameter? Tell me. Najla, is AB the diameter?
No,
No, it's just a chord. What do we call this? A chord. Chord is basically any line joining 2 points on the circumference. This is also a chord, this is a chord, all of these are chords. But the diameter is only if it passes through the center. Now, therefore, because of this rule, I realize that they must be equal. Draw this in your notebook. Tell me when you're done. Proof for isosceles triangle in circle. Since side AC is equals to CB, so ACB or ABC is isosceles. Write this in your notebook. Tell me when you're done. Therefore, angle A is equals to B. Niranjana, are you writing?
Yes, sir.
So whenever I have any triangle inside a circle which is made with the center, okay, that triangle will be isosceles and the angles will be equal. So A and B are equal, not C. C is different. Have you finished?
Done, sir.
Done. Now next thing is this one. Niranjana, read the question.
The diagram shows four quadrilaterals A, B, C, and D. Which one of these could be a cyclic quadrilateral?
Which of these are cyclic quadrilateral? Now read the rule for cyclic quadrilateral from your notebook. Or I'll show it to you right here. Najla, read the rule. Opposite angles.
opposite angles in a cyclic quadrilateral add up to 180 degree.
180 degree. Fine, that's it, okay. So all of these guys have four sides. If I give another option, option E, and it has, let's say, 3 sides, well, it cannot be a cyclic quadrilateral because it doesn't have 4 sides. It's not a quad. It's a triangle, not a quadrilateral triangle. That's out of the chance of the day. Now we have these 4 shapes. Our job is to check which of these has opposite angles. Which of these have angles which add up to 180? How can we prove it? Well, to prove it, firstly, let's try with A. So that means the opposite angle, this and this, must add up to 180. Is 110 plus 82 180? No, that's 192.
Yes.
So then this cannot be cyclic quadrilateral. Is that clear?
Yes.
Now, Niranjana, listen to me. Niranjana,
So
now for the second one, part B, how do I prove if it is a cyclic quadrilateral or not? My job is to prove is shape B cyclic quadrilateral or not? Najla, do you want to try?
Yeah.
Then tell me how.
113 degree, 113 degree plus 67.
So 113 plus 67. And when I add these, Niranjana, focus. What are we doing, Niranjana? We take these 2 sides which are opposite. So these guys are opposite to each other. And I try to add them. If it is equals to 80 degrees, 180, well, it is, that must mean that it is a cyclic quadrilateral. Is that clear?
Yeah.
We'll also try this and this just to be sure. But you don't really have to. You just have to check one. But we'll check one more just to prove my point. And it is equals to 180. Therefore, the correct option is C. So I don't have to check D or I don't have to check C because I already got my answer. Any questions?
No.
Let's try this one again. This question. Now, I wanted to we left this question before because I wanted to do this one firstly. Okay, it is a bit similar to that one actually. Let's see how it works. We found out that since these are opposite to each other, this must be 180. AEC must be 180 minus 45. Why? Because they're opposite and it's a cyclic quadrilateral. This is 135 degrees. 180 minus 45, 135. Now, since look at this triangle. Is this triangle made on, let's say, made in a circle? Yes or no?
Yes, it is inside the circle.
It is inside a circle. So what we realize is this guy right here.
That angle is equals to angle B or angle E.
We don't say E, we say
Wait,
A.
the rule that we just wrote in the notebook, it said that angle A is equals to angle B.
Angle A is equal to angle B, right? What that means is it's just the position. The position means that these 2 small ones are equal, or the base is equal, right? Okay, let's do one thing. Or we can do one more thing actually. Instead of doing that rule, okay, just it's not in the center. Read this rule right here. I'll add one more line here actually. The triangle, write this in your notebook. The triangle must be made using the center. Tell me when you're done writing.
Done.
Now over here, C was the center. Let's make it O. Now over here, actually, we can't use that rule. We can't use it. Why? Because for that to happen, it must look like this. So these angles would be equal, A and B right here, these. But it doesn't look like that, so we can't say that true. But what we can do right now is, I do have a triangle. So how can I use it? Well, I know that the total angle inside a triangle is 180 degrees. So can we find x? What is x?
135 plus 20 minus 180.
So let's just say that's the first step is done. Second step is 180 must be equals to x plus 135 plus 20. Mabata, what is x?
25 degrees.
25. Now, since I know that AC and CD have this side equal, and therefore they must be isosceles, because I wrote it over here. Since side AC is equal to side CD, so this triangle is equal. If any triangle has two sides equal, it's going to be isosceles. So in this case as well, what we realize is, since this and this are equal, this angle will also be x. Is that clear? Which is 20 degrees. Now, why is it 20? Because it's an isosceles triangle. Now, how can I find this? Let's say, how can I find this total angle? Why? Any guesses? Niranjana, work with me. How can I find
Maybe
y?
because it is in a straight line.
Straight line. Okay, all right, that's one thing. But for a straight line, it must be. We must take the whole thing. So this is 180. What we can do here is, since we have another triangle, ACD, right? We have another triangle called ACD. And I know that the angles inside the triangle are how much?
180.
The total angle in a triangle, 180. So, or instead of finding that, let's try to find.
Do we divide it like in each triangle 90-90?
Not like that. I'll tell you how it works. Now, this is the angle I'm trying to find. Now, let's make it somewhere else. Let's make it separately right here. This is my triangle. I know this is 20. This is 20. Now, can you find this angle?
20 plus 20 minus 180.
That's the same thing happening here. Can you see how it's the same thing happening here, right? You have 120, 20, and the big angle over there. It's an isosceles triangle. So what is y then? Y is 180 is equal to y plus 20 plus 20. Namavata, what is y? 140 degrees. So I know that the whole thing is 140. So what is this angle then?
80.
Half of 140.
So the whole
80
thing is
degrees.
140, not 80.
So we have it.
No.
80 degrees.
I'll tell you why 80. Tell me.
20.
120.
120. Who said 120?
Me, Najla.
Because look, what's happening is, since I have this 20 right here, I know the full thing is 140, right? So therefore, 20 and this guy, let's call it k, 20 plus k must equal to 140 degrees. Therefore, when I find k, it's going to be equals to how much? 120. So the angle which they're telling us to find is ECD. Angle ECD is equals to 120 degrees. Now let's try solving this question one more time. All of you, I want you to solve this. I want you to solve this question on your notebook and send me a picture. Since we did it right here, try solving it on your own. Niranjana, work with me. How do I start?
Okay, sir.
They're trying to find that. They're telling me to find what is this K right here. Is everyone solving?
Yeah, sir.
For today's class title and write this as question number 3. Skill check. Now, Niranjana, how do I start solving this? Can you find what is X? Niranjana, Najla, work with me. NA.
Yes, sir.
How do I find X? How do I find X?
It's equals to 45 degree.
Well, it's not equal to 45, no. If I look at this shape right here, what kind of shape is that?
Oh, yeah. Okay.
What kind of shape is that? Najla, tell me.
Cyclic quadrilateral.
Cyclic correlation. So what do we know about cyclic correlation?
So if it's the opposite angles equals to 180 degree.
So opposite angles add up to, not equal, add up to 180. Or opposite angles in cyclic correlation. First step. So I'll find X must be, or 180 must equal X plus 45. Therefore, X is equals to 135. Done?
Sir,
Now,
didn't
second
we
step.
say at first that angles subtended by the same arc?
Yeah, but that is for being equal. That's the second rule. This is the first rule about the cyclic correlation, right? We really don't have to
Yeah.
use that here. So cyclic correlation opposite add up to 180. And if I use the same arc, they're going to be equal. But right now we don't have the same arc. Do we? Now, Najla, now we know X. Can I find Y? What is Y? Najla, can I find Y?
Yeah.
How?
Because it's equals to 20 degrees.
Not 20, no.
I mean,
Look at this shape.
25 because we can use the angle sum property.
Right. Now it's not in the center. So it's not going to be equal.
Yeah, yeah.
Now let's look at this. So we'll just say sum of angle in triangle is equals to 180. So therefore I can again say 180 is equals to 135 plus Y plus 20. So Y is how much? $25 degrees. Najla, can I find this angle right here, G?
Yes.
How? Reason?
No, we can't find it.
Can't find it. Well, since I know that I have a shape like this, let's make it somewhere else. This is my triangle which I have. This one, right? Same thing. But I know that these sides are equal. So that means if this was 5, this will also be how much? 5. If this is 5, this is 5, therefore it is an isosceles triangle. Two sides are equal.
So it's
So the
equals to
angle-
y.
Y and G are same.
Okay.
So if I say Y here and G here, they are equal. Let's call this some angle F. So Y is equals to G. Y, we'll just say isosceles triangle. And we'll say Y is equals to G, which is equals to 20 degrees, 25 degrees. Any questions, Najla?
No, sir.
The rest of you send me a picture if you have finished. Time is over. Lastly, we have to find, can I find F now? Since I know Y and G are both 20, can I find F? Or the bigger angle right here, this one? Najla, can you hear me?
Oh, sorry, sir. I thought you were asking someone else.
No. So Najla, can
Yeah.
I find F?
F? Yeah, we can.
How?
If we find the angle K and we add it with 20, then we can find the F.
But I don't know what K is. And we're actually trying to find K. I know that this guy is 20 and this is also 20. Can I find F?
Yeah.
If you look, if I take this guy there, you realize this is the same triangle. So how do I find F?
20 plus 20, 40. 180 degrees minus 40 degrees. Then we
The
can
reason
find.
will be, what is the reason?
The-
Sum of angles in
Yeah, the angle sum property. 180 degrees.
equals 180. We'll just say F is equals to 180 minus 20 say 180 is equals to 20 plus 20 plus Y. So Y is equals to 140. Done. Now last step. If I know K and 20, I know these guys, and they must be equal to F. Can I find K now, Najla?
Yeah.
How do I find K?
Subtract 20.
So I'll say F is equals to
140
plus
minus
20.
20.
And so therefore K is equals to 180. Now 180. F was 140, so 140 is equals to K plus 20. Therefore K is equals to 140 minus 20, which is 120. So our final answer is how much?
120.
120. Because they're asking us to find this ECD. K. Any questions? Now the rest of you, do you understand? Any questions, anyone? Mawadda, Diana, doubts?
I have sent my answer, sir.
Sir, I'm gonna send mine.
Mawadda,
Sir, I'm stuck.
stuck where?
I'm trying to find like the ECD angle. I found out the.
So show me your
Sir,
work and send me a picture.
After you're
Okay.
done correcting mine, I have a question to ask.
Ask me.
Why are we like taking like bringing extra letters like Y, X, and G? Why can't we do it the same way it's given?
You can. You don't have to add extra letters. I'm just trying to make it easy for you to understand. Because it would be more complicated if I say ECD, right? If I say ACD, that's longer. But in the exam, you can draw on the diagram and tell them what is Y and J by marking
So
it
can
like
we
this,
just
or you
like
can,
add these without like the Y, X, K, and G? Like, can we add it into
No.
the figure that we're actually drawing?
well, you can do that, but I would prefer you don't do that. Don't call this guy A, call this guy E, call this C, call this D. Okay? Because
So it
that
should
will
be
not
rough
be true.
for our
You should
knowledge.
use, yeah, for your knowledge, use different letters and write it in your exam. Use like this, X, Y, K, and all of this. Some other than what is over here. Don't use A right here, or use this, the whole thing, CAE. So Y is equals to CAE. Niranjana, Niranjana. Now this one, that's Mavadda 140. Right, I think Mavadda is stuck, right? Mavadda, were you the one who was stuck?
What?
Mavadda, have you finished it or did you have a problem?
No, sir, it's incomplete. I have a problem.
Right, exactly, all right. Okay. Okay. Yana, have you done only this much?
Sir, I'm still writing.
All right. Okay. Now, Mavadda, look at this. We know that AOC, ADC is 25, fine. And I know that ECD. Now, okay, Mavadda, there's a problem here. It's not ECD which you're finding. You're finding ACD. What is this one? ACD. So let's take it right there. If you look at this, you'll realize that this is the angle you were finding F, which is ACD. So 180 plus 20 plus that's plus ACD is going to give you that much. Now I know that angle ACD is 140. And I also know that angle ACD is equals to how much? Angle ECD plus 20 degrees. Look at this. This angle is basically this whole angle ACD, and you have two angles inside it. So 20 and K, or this angle ECD, must add up to the whole thing. Is that clear?
Yes.
So I'll say that ACD is ECD plus 20 degrees. Therefore, 140 is equals to ECD plus 20. Therefore, ECD is 20 degrees. Any questions?
No, sir.
Diana, have you finished?
I'll send you, sir.
Najla,
Yes, sir.
we did it together, right? All right, never mind.
Yeah.
Niranjana,
Sir, is mine correct?
yours, I haven't seen it. Lola, send it again. Send it.
I sent it.
I haven't received it. Niranjana, I can't hear you. Why? Now look at this one. Yep, that's correct. Now I'll just show you the other rules and we'll end the class, right? Najla, read the third rule.
Okay. Angles in semicircle are 90 degrees.
Are 90. So if I have a semicircle, what does that mean? That the side, this must be the center, the diameter. If I have any triangle with a diameter, the opposite triangle, the angle right here will be 90 degrees. Always.
Sir, I have a question.
Ask me.
Isn't like semicircle like half of the circle?
Yeah. So let's see how that works. So if I make a circle like this, and I'll make a diameter like this. Now I'll remove the other half of it. Let's also make a triangle. Let's say anyway. I can make it anywhere. I can make it here. Done. Now if I remove the rest of the circle from here, is it now a semicircle? Is this a
Yes.
semicircle? Yes. And if I make an angle in this semicircle, it will always be 90 degrees. If I make it here, if I make it here, it will always be 90 degrees. Is that clear? So we're only looking at the top part of the circle. In the same way, if I bring something else here, if I, instead of making it at the top part, if I make it below, let's rotate it. This is also 90 degrees. Is that clear? Any doubts? Because
No,
this
sir.
is a semicircle. That's a semicircle. Now, I think that's fine. For semicircle, quadrilateral is fine, right? Okay. We look at one more rule. If you have a circle, and I make something called a tangent, which will only touch the circle at one point. Only at one point. This line, how many areas is this line touching us? The second line. Touching the circle.
It's crossing the circle. It's breaking it into two halves.
Into two halves, or not really half. Let's curve it a bit. Just say, make it like this. It's crossing at 2 points, right? So that cannot be a tangent, can it? It's not a tangent. Tangent is this first line. Now tell me if the third line is a tangent. Green one. Is this a tangent? Mavada,
Yes, sir.
is the green line, the third one, a tangent?
Yes.
Write in your notebook, tangent is line that touches at one point. Write this in your notebook. Now, since third line when you touches at one point, that's a tangent. First line touches at one point. What about the fourth line? Najla, is this a tangent? The fourth one.
No,
Because why?
because it's not. It doesn't touch at one point.
1 point. Now, if I remove the other ones, and let's just talk about these guys. Let's say this is A and that is D. And I've sent it O. Now, what is this line called? OA. What is OA called?
A radius?
Radius. Now, this is always going to be radius, and the angle between a tangent and the radius is always going to be 90 degrees. How much?
90 degrees.
Najla, read this rule out loud.
Tangent line that touches tangents from one point of equal angle between tangent and radius is 90 degrees.
90 degrees. What that means is, if I have this radius right here, this is going to be 90 degrees. So is this going to be 90 degrees? Fine. But there's one more line here. Tangent from one point are equal. What does that mean? Well, if I, let's say, instead of making this circle, I'll make another circle right here. Now, Lula, add this to your notebook. Send me a picture of the fifth rule in your notebook about the tangent. Send me a picture. Now, what we realize is, if I take only one point here, let's say point F. From this point F, I'm going to make two tangents. This is one tangent, and this is the other tangent. So how many tangents can I make from one point? Najla?
2 times.
2 times only. I can't make a third one because, well, that's taken. If I do this, that's not a tangent, not a tangent. Only at 2 places. What we realize is this point right here and this point right here, that is where it's touching. So let's call it G and H. And I have centered O. Now this line, what is it called, Mawadda? OG.
Sir, can you repeat?
What is line OG called? Or OH?
A radius.
Radius. So this is a radius, this is a radius, we know that. Another thing is GF, can you see the line GF right here? And the line HF. These are going to be equal. So write this in your notebook right now. Write this as tangent rules 5. Tangents to circle. What is tangent? Tangent is a line that touches one point. This angle is going to be 90 degrees. This is 90 degrees. And the only thing remaining is that the point GF and HF are going to be equal. Let's write that right here. So, angle between radius and tangent equals 90 degrees. And 2 tangents same point are equal. What that means is GF, the line this one, is equals to line HF. Finish writing, tell me when you're done. Lula, can you hear me?
Yes, sir, I can hear you.
In this line, rule 5,
So
which you
where
wrote in
is
the
F?
notebook. Where is? Yes, Niranjana, tell me. This is
No,
F.
sir. Nothing. I got it.
All right. Now we can also make a triangle like this. So we have 2 triangles, OFH and GOF. Write this in your notebook, make a proper diagram. Lula, I want you to change a few things here. First thing is, everyone, whenever you're making a diagram, make it with a pencil, write with a pen. Make this a habit. Don't write and draw with a pen. Don't write and draw with a pencil. Draw with a pencil, write with a pen. Make the difference. Now, just one thing, Lula, make the angle right here, 90 degrees in your drawing. And add the second point right here. 2 tangents from same points are equal. Fine?
Which
GF,
point?
the second one. 2 tangents from same points are equal. This one, because you have already written the whole thing. Only this thing is remaining. So write it right over here actually.
Sir, for knowledge, I'm not writing the same thing that we wrote previously. I'm rewriting everything again.
But why?
Because it will be messed if I rewrite everything in the same page I have written it. So I will redraw everything and rewrite everything from the previous ones and add everything you told me to add.
Don't do that, please. That would take a lot of your time. Or just write rule 5 again. The only thing which has changed is this part. That's it. Everything is exactly the same. You can draw this again.
I have
Najla
done that.
finished?
I have done that.
Perfect. Najla,
Yes, sir.
have you finished drawing?
Yeah.
Mavadda,
Yes, sir.
have you finished writing?
Yes, I have.
Diana,
Yes, sir.
okay. Let's just write the last rule. Niranjana, have you finished? Niranjana,
Yes, sir.
rule 6 is the final one, which is, let's add it right here. Angle in opposite segment is equal. Or not opposite, sorry. Write it differently. Angle in alternate segment is equal. And this is called alternate segment theorem. The final thing is just make a circle. If you have any triangle with a diameter, this is the diameter, by the way. And I have a triangle with it. Can you tell me what is this angle? Diana. This angle right here, angle A.
Can you repeat?
The question is, what is angle A? How much is it?
Can I say?
90.
No, I want the answer from Niranjana. Niranjana, what is the answer? Tell me quick. What is A? The rest of you finished writing.
Yes, sir.
What is angle A?
Will it be 90?
Will it be how much? Quick, say it.
90?
Yes, 90. So what we realize is angle CAB is equals to angle BCF.
Sir, in the ones that you gave us previously, we have written that A equals to B. And yeah, the A equals to B, the one down. and A plus C equals to 90 degrees.
Right, let's do that right here. A, B, let's call it B. Now that's the problem, right? Because I tend to change things a lot. So we need to study things once and then finish more topics because all of you are quite behind on syllabus. Let's write it here. So A is equals to B and A plus C is equals to, not A plus C, B plus C is equals to 180 degrees, 190 degrees. Why? Because we know that this is a tangent and this whole thing is a radius.
So do I change it to B plus C?
What did you write previously?
I wrote A plus C equals to 90. And A and C is a straight line, like A and C, the one there.
Like this?
Yes.
Finish writing.
Do I write angle CAB equals to angle BCF?
Yes, write it. Because we need to realize all we're doing is that this angle right here is going to be equal to the other one, which is not 90 and which is not along with it. We know this because we can prove it. Have we finished, Mavadda?
Yes.
Niranjana?
Yes.
Rihanna?
Yes, sir.
All right. Look at this question. Niranjana, read the question.
In the diagram, PT is a tangent to the circle P. W is diameter and angle PQ is equal to 40.
So they're telling that PW is our diameter. Okay. Well, fine. But how does that help me? Right? I still have no clue what is, they're asking you to find this angle, PWQ. PWQ. This one. Can someone tell me how do I find this?
We know that angle at a semicircle equals to 90 degrees.
Okay. That is 90 degrees. What about this one? Let's call it angle X. Mavadda, what other property do we see here? We have the semicircle rule. What other rule can you see over here?
The tangent.
Tangent. So which
Yes.
angle? What does it tell us?
A line touching
That's-
only one point on a circle.
That's tangent. All right, good. That is tangent. So T is a tangent. PT is a tangent. Now, what angle can I find? What does it tell us about the radius? If I call this center O, and what is OP then? Is OP
OP is
radius?
90. Yes.
So what is the angle OPT? Now everyone, I need the answer in the chat. Najla, can you hear me?
Yes, sir.
Now tell me the fifth rule. What is it?
The tangent one.
Yeah, the tangent one.
It's a line that touches the circle at one point.
Okay, and what do I get? What do I realize from that? That is not the rule. That is telling us what is tangent. Right?
Yeah, the
Where's the
line
rule?
OP equals PT.
No. No, we don't
And
know that.
OP equals to OW.
Well, we know that. Yes, both of them are radius. But the thing is, what does it tell us about radius and a tangent? Let's go back
Yeah,
right
it's
here.
equals to 90 degrees.
It's equal to 90 degrees. Now, please put this sign over here. This sign. So, you know what is important. And two tangents are equal, not the points, not any points, but two tangents. Now, okay, that's fine. Okay. The last thing was rule 6. Rule 6, you've written it. Now, I know that this guy is 90 degrees. Can I find this? What is this then? Green angle.
90 plus 42. Wait.
No.
90 minus
Niranjana,
42.
90 minus 42. What is it? Niranjana, what is this one? WPQ.
It's 48.
48.
Total, it will be 180.
The total will be 90. Yeah, total will be 180 from here, the whole thing. But I know that this much is 90. And I know that, okay, if this is 90, and these two angles are made with the same area line as well. So I realize that 42 plus this angle will be equal to 90. So therefore, WPQ must be 90 minus 42, which is 48 degrees. Because the whole thing is 90 and this is 48, 42. I know this. Now can I find X?
X
What is
equals to
angle?
48 plus 90 minus 180.
Yes, so WPQ is 180 is equal minus 48 plus 90, which will give us 48. So what is
42.
the answer? 42? No. Check
48.
again. 48. No, not 48, sorry. It will give us 42. 42. Now, how can I solve this then? Well, I know that this is 48. I got the answer 42. Write the whole thing in your notebook. Question 6. But can I do one more thing? Can I use rule 6 over here? The rule is if I use this one and this one. Let's just look at the question. Can Niranjana read rule 6? Niranjana read rule 6. Out loud. Najla, read rule 6.
Angles in a alternate segment is equal alternate segments theorem, which is called alternate segment theorem.
Okay. So, Lula, does this remind you of something? Can I find what W, what PWQ is directly, without anything, direct step. How can I find it? If I make a circle
Find
like this,
PWQ.
this is what I have. And we know that the angle right here angle B is equals to this one, the one outside, always.
Wait, is it like the angle CAB equals to angle BCF?
This one, look. If you look at it, we'll realize that this is what we had so far. And this angle opposite, these two angles are always equal. So if this is 20, then this is 20. So if this is 42, this is 42. Mawadda, do you understand?
Yes, sir.
Diana, work with me. If I look at the tangent, if I have any triangle with it's formed by the diameter and I have a tangent, then this angle, which is right here, will be equal to the one opposite to it, right here.
Yes.
And we know that diameter always makes 90 degrees. So this is 90, that's fine. But we don't care about that. All we directly know that since alternate theorem segment theorem, this 42 will be equal to this guy right here. And the reason, 1 mark for the answer, 1 mark for the reason, is alternate segment theorem. Lula, do you understand?
Yes.
That's it for now. Now we finished angle properties. We finished angle properties in the last class. We finished circle theorems now. Tell me, when do you have the next class on this topic? On maths? Which day?
We have maths by next week of Monday.
Monday. So you have a test on this angle properties and circle theorems on Monday. It will be a 50-mark test. You will have worksheets in the GCR. You can discuss answers in the group in the weekend and today as well. Yes, Rihanna?
50 marks?
Yes, 50 marks.
Sir, before this, can we have like exercise questions that we can practice?
Yeah, you'll have it in the GCR. A worksheet. You'll have 2 worksheets on these chapters. I'll upload it in the GCR. You can discuss it in the group and also ask me doubts in the group. Fine?
Okay.
But you have a
Okay.
test on Monday, all of you. Now, Lula, recap, what did we do?
In this class, we studied about circle theorems, and we redid all the 6 rules that we had.
Perfect. And you got the isosceles triangle. That is new.
Yes, we added a
I
new
hope you-
isosceles triangle.
That's it. Now, in the next class, you'll have not a recap, sorry, you'll have a test. All right.